Good morning and welcome to Superhouse Squirrel Sunday. Someone just said, some call it fun, said looking forward to some squirrel wrangling. First, I acknowledge the traditional owners of this land. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And we have a whole bunch of people in the chat. Good morning to Mitchell, who was in way too early. Station 240, Dodgy's here. Some call it fun. Chip and Chris, Cabletti, Peter, and the list goes on. Jax Tech is back from his trip, so Jax Tech has been in quarantine. I hope that all went smoothly and you didn't go too crazy. All right. Mike Carden. Awesome. So there is all right, how to begin this? I don't know how to begin this. All right, we are going to do the PCB today. I'm going to get back into Fusion. You can probably hear that dog barking in the background. It's a neighbor's dog. It barks all the time. Anyway, you can see me trying to figure out what I've got to say. All right, so I feel like this first part should come with a parental warning or something. Mitchell, thank you for contributing to the Squirrel Fund. What is ZAR? I have no idea what that currency is, but it sounds cool. ZAR. It's very pirate-like. All right, so not even sure how to talk about this first bit, and I was wondering whether I should talk about it at all, but I think I will. It's a serious squirrel. It's a major deviation from anything home automation related or the normal sort of tech stuff that Rand, okay. ZAR, so ZA for South Africa, of course, and R for Rand, ZAR. Makes perfect sense. Thank you. So, okay. Where to begin with this? I got to set up a little bit of background. Now, over the years, something that I really don't even know how to talk about this, so I'm just going to bumble my way through and try. My assessment of myself, which of course is never going to be objective or anything else, is that I have a reasonably even sort of level of emotional level. I don't tend to get very upset or I get excited about things, but I don't fluctuate very dramatically. I tend to be reasonably even. And one thing that some people say to me fairly regularly, so hopefully it's a reflection of reality, is that I'm very patient. Like when I'm dealing with situations, things don't seem to bother me too much. And dealing with people that could be frustrating, I don't ever tend to react to it. And over the years, I think I've developed a bit of a stoic approach to life, and so I hesitate to call it a philosophy because I'm not qualified to talk about anything like that. But I think people like Marcus Aurelius had some good ideas. They were on the right track with some things, and when you look at how you fit within the world, or when I look at how I fit within the world, I recognize that the vast majority of things are beyond my control. Other people have their reactions to things, they will do things, they think things, there are events that happen, and I can't influence them in any way whatsoever. Everybody has their own way of approaching things, and the only thing that I have any control over is my own reaction to them. So one of the side effects of that is that it's when people do things that I think are bad or ridiculous, I don't tend to react very much because I can't necessarily change them. And you might think that that means that it's giving up on everything, but it's not. That's not the right way to think about it either. It's not a matter of just saying, "Oh, nothing matters. I don't care about anything," because I do care about things, and I get excited about things, and I want to achieve things and do things. But it's just this recognition that there is my reaction to situations versus the things that I can control. And this has changed over the years. Like the way I think about things has changed over the years. Hopefully everybody learns and grows and gets new things. Audio level is low. Okay, let me see if I can fix that. Now I changed microphones right before the live stream because I'm pretty sure I can fix this, because my camera setup has changed. I'll show you that in a moment. We will get to that. But in the meantime, I'm just waiting for, okay, external microphone input volume. I'm going to turn it up. All right, let's see if that is any better. I've just cranked it up a little bit. Dodgy says control is an illusion. Yes. Yeah, cool. Hopefully the volume is a bit better now. So if someone can give me a thumbs up or whatever, please let me know. Yeah, so you're right, Dodgy. Control is an illusion. Thanks, Mitchell. What I'm getting at here is I'm just trying to set some... good. Thanks. I'm trying to set some context for something stupid that I did on Friday. And it was a very childish reaction to a situation. So over the last few weeks, I've had, things have been getting to me a little bit more than they have in the past. And so I've been on, you may have noticed that I haven't been on Discord, and I haven't been doing much on Twitter and Facebook, just posting a little bit occasionally, maybe most of the time just scrolling through and reading it myself, but I haven't been engaging much. I've been kind of disconnected the last few weeks, and I've had this thing where if you think about patience as being like a fuel gauge, my fuel tank has been getting closer and closer to empty until my patience was totally done by Friday, and I had nothing left. And so Friday evening, I was in a situation where my level of frustration boiled over, and I had a reaction that was a tantrum like a 4-year-old. And Jack's Tech says running low on spoons. Yes, exactly. I just couldn't deal anymore. And a certain situation that is recurring or ongoing, either way you could look at it, was getting to me. And this is the bit I'm trying to avoid getting to this point. I should just get through it, because it's once I say it, it'll be all over. It's too late. It's live stream, so I can't take it back. Anyway, I got to this point on Friday where I got into that state where it's the classic thing of I saw red. I was so frustrated that I just didn't know what to do. It was like it was coming out in all directions. And oh, Ishmael, thank you very much. So it was coming out in all directions, and I didn't know what to deal with it. You know what it's like when little kids have tantrums and they're so angry and they don't know how to express themselves and they don't have the emotional control. And that was me on Friday. But I was on a phone call at the time, it got to this point where I couldn't even think straight. I was so frustrated, and I just wanted to, I wanted to smash something. Like it just came out that way. And, but I had to be quiet. And this is the embarrassing bit. I ended up punching myself in the head very hard several times. Like just one of those rage sort of things. And I kind of hurt the side of my head. No, I did not get any of this tantrum on video. Anyway, trying to do self-analysis as to why this happened and my lack of ability to... I think it was because there was no... I couldn't walk away from the situation. There was no pressure relief valve, and eventually things just come out in whatever way happens at the time. And there are so many implications to this. It comes into... so I totally directed this at myself. I didn't direct it at anybody else. And so... But this sort of situation... Oh, I don't even know if I want to get into this. This is... no, I'm not going to go down that particular angle that I was thinking of talking about. Anyway, I was out of spoons. My patience tank was drained. I took it out on myself physically and had a headache for about the next 16 hours. In fact, there's still like bruising on the side of my head. Yes. Gerald says, it's a great story. I'm a bottler. Once things reach a peak pressure, I lose it. Yeah. Yes. All right. Paul says, have kids and this will be a daily occurrence. I have 2 kids. My 2 kids are awesome. But they are old. When I say old, I mean 16 and 20. So they are... it's beyond the stage where I've got little kids running around that make me lose it like that. Oh, James said, I've been there, done that, mate. No one's going to judge you for it. I lost it at a random guy that honked me one day. I can highly recommend the book, The Chimp Paradox. It helped me a lot. Cool. Thanks, James. Yeah, road rage. That's an interesting one as well. That's one of those situations where this comes out a lot. Now, I don't want to... So, yeah, there are certain circumstances. There's domestic violence. That's the topic that I didn't want to get into. Road rage. There are all these situations where people react in an emotional way, or yeah, I'm not qualified to talk about any of this. I just wanted to convey to you something that I'd experienced and explain. Not really explain, but part of the reason that I've been a little bit invisible the last few weeks. But I'm doing better. Michael said I road commentate rather than road rage. That's when you... yes. Yeah, pancake. So Andrew Nielsen says, I've been saying for many months that lockdowns will have long-term mental health problems. This is a mental health crisis and it's not broadly talked about. Yes, good point. Yeah. Now, if I hadn't been... The thing is that most of the time, pretty much every time this sort of thing has happened to me, and I've got to the point where I've had this level of frustration in a situation, there has been some way to deal with it, like to really let that that pressure go. And it could be, going out and hitting the punching bag for a while, or just walking away is great. Remove yourself from the situation, and that's generally what I do. So if I get to the point where the frustration is too much and I'll think I'm not being productive, I'm not reacting in a useful way, then it's time for me to get out of that situation and then deal with it when I can be a bit more balanced about it. It's just that in this particular case, I could not leave the situation. Yeah. Yes. Scott said, good tip for those times when punching inanimate objects becomes necessary. High quality cabinetry will break fingers off. Yes. Yeah, you have to be careful about what you hit. And absolutely, definitely do not ever hit someone else. That is the #1 cardinal rule. Okay. Yeah, so way back when, in fact, when I started doing these regular weekly live streams, it was when we went into the very first lockdown here in Melbourne. And it was a way of I just looked back at some of the comments. Dodgy says, you're lucky you only have a bruise. I have a hand that is cut to pieces because I punched a beer glass. Oh, man, that's bad. Ooh, I hope that healed up okay. And Sion said, did you let go of your phone before you punched your head? Or was it in your hand still? It was the other hand. I was holding the phone and I punched myself with the other hand. Yeah. Where was I going with this? I've lost my train of thought. Totally. Oh, this is interesting. This is okay. A couple of stories. Delane said, many times I'll walk away before I throw a wrench. Yes. When I was maybe 19 or 20, I was with my friend Andy just sent me a message. I saw it pop up on my phone with some good advice. Yes, Andy, we will follow your advice. I'll get to that. And his advice was some communal hacking is a good way to get past this sort of thing. We will do that in just a moment. So when I was about 19 or 20, my very good friend Adrian, who I haven't seen for many, many years, he ended up moving to Japan, and then I think from Japan moved to Queensland, lost contact with him. And I haven't seen him for years. But back when I was in uni, we used to do all sorts of stuff, mostly working on cars, like doing engine swaps and that sort of thing. And we used to do lots of stuff with rotaries. Anyway, working on a car with him one night, I think it was one night, so like dark, in his driveway, and there was a Mazda RX-3 that he was working on. Was it the RX-3? Might have been a different car. I think it was his RX-3. And he was trying to get, so the bonnet had been removed. I think he was trying to remove the exhaust manifold or something like that. And he was in the engine bay with a wrench trying to get, nuts off the exhaust manifold so he could get it out. And of course, exhaust manifolds end up sort of rust welded on over time. They can be a total pain to get off there. Because they go through such extreme heat cycles, they just, yeah. If you've ever tried to get one off, you know what I mean. So he was frustrated. He boiled over. He was there leaning over the engine bay of the car with this spanner in his hand, and he totally lost it. And I just realized I probably shouldn't have said his name before I started telling this story, because he may not want me to tell the story. Anyway, he totally lost it and smashed the windscreen of the car with the spanner that was in his hand. And it's one of those situations where you're trying to make things better by fixing something, and then you make things worse for yourself because you lash out and do damage that then becomes something that you have to repair when you didn't have to repair it before. Then new windscreen time. Great. Yes. So Michael Wire says rotary equals vibration generation device. Yeah. Particularly, yeah, this RX3 had a Bridgeport in it for a long time. It had a few motors in it. We ended up doing lots of motor swaps and rebuilds, and but yeah, the peripheral ports just sound nasty. They're really cool, but like a fairly extreme Bridgeport rotary, when it's idling, it just sounds awesome, and the whole car shakes. It's like anyway. I've been talking for 23 minutes now about this. So, yes, we're chasing squirrels. There was one other story I wanted to tell. What was that one? Yeah, not so much a story, more like a counter observation. Many of you will not know, although Chip, who is in the chat here, will know because he was at school with me. Right after school, I ended up working for a company called New Breed Security, doing security work. A little bit of security guard sort of stuff, but I hated that. It was boring as hell, just standing around in the dark for hours and hours. Mostly crowd control and a bit of personal protection for VIPs, like mostly musos, but also for sports people. And I spent a lot of time hanging out in nightclubs. And I've never really been one for drinking or anything, never really been one for nightclubs. So I would always be, 100% stone cold sober, standing around in a nightclub while everybody else is drunk and dancing and getting emotional and fights are breaking out. And it's strange when you work in nightclubs, they totally lose their magic. Not that they ever had much magic for me anyway, but it's like going to a circus in daylight and you see how crappy everything is. Like if you see a typical nightclub during the day with all the lights on and you see how broken stuff is and the paint coming off the walls, at night when there's music and lights and things, they seem like a magical mystery land, but they're just nasty, stinky rooms. And anyway, the point of all of this is that there would regularly be situations like people would get into fights and we'd have to break them up. We'd throw people out. And I was always stone cold level-headed through everything. I don't remember a situation where I ever got angry or frustrated or anything like that. Like I could be dealing with someone that was trying to punch my head in. And it was just like, oh, well, they're there, they're doing it. So just got to deal with the situation, grab them, control them, take them outside. And yeah, so I think, and that was back when I was like 20, so 21, 22. And I think I've been fairly level-headed even back then. It's not necessarily something that has developed as I've become old and grey and then lost my hair. So anyway, yeah, Scott Miller said, nightclubs always smell like puke during the day. They do. They've always got that smell. They've got that stale beer and puke smell. They're disgusting. Oh, right. Johnny Begdale posted the Office Space printer scene. Yes. Take your rage out on it. All right, now, I think that is totally enough of that topic for now. I partly wanted to cover that just to explain why I have been absent recently, and also it's a way of showing that everybody deals with this stuff. It's easy when you're feeling bad in some way, either depressed or angry or, having some extreme emotional reaction to situations to feel isolated and that you're experiencing it, but it's not normal, or that there are other people that don't experience it, but I partly wanted to share it to show that everybody experiences it. They may not experience the same things, but everybody goes through these sorts of things and has to deal with situations. So, if that's you, please find someone to talk to about it. I'm talking to you. All right, so now, now someone was wanting to post a link, and there is a problem that you have to be a mod to post a link, but I think you Gerald says, "We are people, not statues." Yes, that's right. I think that, sorry, I'm thinking about the posting URL. So I've missed a whole bunch of stuff in the chat. I think someone wanted to post a link, but they couldn't because they're not a moderator. And I've missed who it was actually that was wanting to post it. Link sorted already. Awesome. So I think the deal is if you can post the link, but it won't go live, and then a moderator can approve it or something. So all sorted. Very good. Now let's go into some nerdy hacking stuff. And I'm going to start off with last week at the end when I was messing around with that comparator and it wasn't working properly. There was a silly explanation. It's one of those things where I couldn't see it because I was in the middle of trying to do the live stream and talk while I was doing stuff. And it was because I had been messing around with that circuit previously. I had swapped the capacitor in the RC network, and the value of the capacitor was 2 orders of magnitude off what it needed to be for the frequency of what I was feeding into it. So I fixed that. It works. Now we can do it and we can look at it and you can see how the comparator works. And I think it'll all go smoothly this time. But just before we do that, I'm just going to show you something. I've just been rearranging things a little bit. So I'm going to switch to DroidCam, go for a mobile camera view, because I've just been moving some stuff around. In the past, like if you're looking at my front camera now, you would have seen the overhead camera sitting about here, pointing straight down at the bench, and it's not there anymore. But if I go here, you've got overhead camera. And the reason is, I'm going to go portable. I'm going to back up slowly so that I don't make you seasick. Now I'm using a fixed microphone at the moment, so as I get further away, it's going to get quieter. Backing up, backing up. The camera is now right up there. It's mounted much higher and it's got a different lens on it. Previously, I had a 1442 zoom lens. Now it's got a 45 to 150mm zoom lens. I'm going to back way up over here, and look, you can see yourself. You can see the so if I point, where? There. Okay, so workbench there. The old position of the camera was about there, pointing down, so it was that distance. Now the camera is up here, pointing down, so it's much further away. And the zoom range of that particular lens at that location is much better than the zoom range of the old lens at the other location. So it now brackets the level of zoom that I want much better than it did before. So, so I'm now able to zoom in better on small things, and I can also zoom out and get the whole bench. And being higher, it's out of my way. When it was just here, I kept bashing my head on it. Like I would walk up here and the camera would be sitting right in this position, and I reach over and knock it with my head. Now it's above head height, so it's improved. So if we go to overhead, you are now looking at the view. Just going to give the scope a kick in the guts, and you're now looking at the view from the camera that is way up there. Now, one thing that concerns me slightly is that because it's now a longer lens and it's further away and it's zoomed in more, it's going to accentuate any vibration. So if there is anything that makes that camera move, it's going to look like everything here is moving. But just as an experiment, I'm just going to try bashing the bench. Yeah, you can see the camera wobble. And that's being transmitted all the way through up to the bracket. So, I mean, I hit the bench pretty hard then, but still. So I might have to do something to stabilize the camera mount. All right, so let's get this going. We have the function generator here, which is currently set to make a 10 kilohertz sine wave, 2 volts peak to peak, and that will be coming out on these two alligator clips right here. So let's see what we can set up. Now I've got a couple of probes here. I've got the two probes coming off the scope. All wrapped around each other, of course. Oh great, I just knocked the other camera. All right, let's fix this. All right, that's better. So now we have scope cam, and all right, so what we have here is this Wemos Lowland 32 is not actually being used for anything right now other than its power supply. All I'm doing with this is taking 3.3 volts off it. There's a bunch of wires there. Most of those are actually doing nothing right now. The only thing that matters is we are taking 3.3 volts and ground, so that is powering this comparator. And that's it. The rest of that circuit doesn't matter. All that matters is the comparator, the resistor, and the capacitor. And this doesn't matter either. That's the input from the multimeter. I'm not even using that, not using any of that. The whole point of this is just to show what the comparator does. So what we've got is the input to the comparator is here, and we've got a ground connection here. So what we can do, this is the output from the signal generator. I'm going to connect ground, and the signal generator output is going to the input of the comparator. Then, from the oscilloscope, channel 1, I'm going to plug in, I'm going to connect ground, and I'm going to stick that onto there as well. So the idea is that all the first channel on the scope is going to do is show us the signal coming out of the signal generator. So I'll turn that on, and you can see now that there is this nice little sine wave excuse me, this nice little sine wave coming in on channel 1. So we're generating it here. If I change settings on this, we'll see it change on there. But anyway, it doesn't matter what it is. So the point is that what we're doing is generating a sine wave, which is representing a signal that is rising and falling, but that is very noisy. And so what we want to do is discover when is the signal rising and when is it falling, and clean it up into a nice little square shape instead of having this. Yeah. So the sine wave could be, this is just a stand-in for the data that comes from the multimeter. So what we can do now is take the output. Where is the output? Oh, here it is. So this is the output pin from the comparator, and I'll hook that up to the second channel, and we'll see some signal coming out of that. All right, so we can see a signal on the second channel, but it looks a little bit on the bizarre side. Now, let's, I'm just going to scale that up so you can see it a little bit more clearly, and I'm going to move it up the screen a bit. There, okay. So these voltage scales are different on those two channels, but that doesn't matter. The point is to show how they correlate to each other. So the yellow trace here is the one that we are reading from and analyzing, and we want to turn that into a nice square wave. Now you can see that the blue is not a nice square wave. It's doing some really weird things. And if there is a perfectly good explanation for that we'll get to in just a second. So what we're expecting to see is where the yellow signal starts to rise, we want our comparator to detect that as a high and go high, which it does here. So our signal goes up, it begins to go up, and it goes high. And then it stays high, and then the signal starts to go down, and then the output of the comparator drops to a low level, and it gets to here. As the voltage here falls, then it goes up, it's got this weird little spike, and then it goes back down again to where it should. Now, what should be happening here is this blue trace should be high while the yellow is rising, and then it should be low while the yellow is falling, high while it's rising, low while it's falling, etc. Now, the reason that it is doing that weird thing, and we can fix it right now, is that the input of the comparator is not, it doesn't work fully rail to rail, which means that if the value that is coming into it is not within a certain window of its input that it can deal with, then you get this weird sort of artifact. So what we can do is we can change, so we've got sine on here, I'll change the offset value. Now if I go across to, I'll move across one, where are we? So I'm trying to look at the other, yeah. So I'm going to work in millivolts. I'm going to take that up a couple of millivolts. There we go. So I've taken it up 300 millivolts, and at that point, I'm going to take it up a little bit further, 400, 500 millivolts. So beyond that point, it looks like it pretty well matches what we expect. So now you can see, once the yellow trace gets to its bottom point, so it's no longer falling and it begins rising, the output of the comparator goes, whoa, we're on a rising level, so bang, let's take it high. And then it gets to the top. As soon as it starts falling, it says, oh, we're now on a falling slope, so bang, pulls it low and then holds it low. So what that allows you to do is take a noisy signal or a signal that is sort of fluctuating and square it up. It lets you get a very clean signal coming out of it. Okay, did that explanation make any sense? Yes. Alrighty. Now, when the second needs to be thrown, it won't bounce off the camera. Yes, Scott. True. Yeah, so, oh, and Dodgy said, or an isolator bar. So this is the conversation about the overhead camera. There is actually a reason that it is very susceptible to vibrations, and I know how to fix it. Let's go back to portable. Is this going to work? Yes. All right. Now, the way I'm trying to move this camera slowly because portable cameras make people feel really sick. It's a horrible effect. So what you can see is this camera is mounted. That's like a quick release mount, like off the top of a tripod. And then it's mounted onto this metal bracket, which I just bent into an L shape. That is screwed onto this drawer slide. So this is a slide that is normally mounted horizontally for drawers, but I can push it in and out, and that way I can adjust the position of the camera. I can push it all the way in, and then the camera is out of the way, or I can just grab it, drag it out, and then it is over the position of the bench that I want. But because it's only a single drawer slide, you can see if I get the camera right on the end here, it has a tendency to rotate like that. It's not very stable, so if I do that and make it shake, it will just keep penduluming for a little while. So the way I can fix that is I can put a second drawer slide beside this one, put a plate across between them, and then mount this so that it doesn't have this rotation, and then the whole thing should be very stable. But first I need to find the other drawer slide. So this drawer slide, which is the one that was mounted here under this bench, I bought it as a set of two. I've got to switch back to the other camera, get rid of that motion sickness effect. And yeah, so I just went down, it was a few years ago, I just went down to Bunnings and bought two drawer slides, they come in packs of two. And I used one for the camera mount, and the other one I left in its bag, put it in the garage, and thought if I ever need it, I will have it. I've spent a lot of time looking for it. I've got no idea where that second drawer slide went. But it was years ago now. It was a few years ago that I bought it. If I can find it, I am going to mount it beside the first one, plate between them, make a nice stable bracket that can't rotate, and then it should all be good. So, in my head I'm already starting to think about where could that thing be. I was just about to go off and start looking for it. Note to self, do not do that during a live stream. Right. So, Gerald42 said, which op amp are you using? It's a comparator. Scott said it's hiding behind the box of failed projects. One box? Not just one box. It's a comparator, not an op amp. And, well, comparators and op amps are very, very strongly related to each other. I can't even remember what the part number of this one is. It's one of the super common ones. Chuck it under here so I can use the old Mark 1 eyeball to figure it out. It is an LM393, which is a very common, cheap dual channel comparator. Alright. Station 240 says, shipping container of failed projects, that's more like it. Now you're talking. Okay. Anyway, that whole comparator thing has occupied parts of the live stream for weeks. It's gone on for so long, and I think we can finally put it behind us now. Turn off the scope so that we don't get that that noise. Hang up the probes, up out of the way, and I will clean up the rest of this mess after the live stream, I think, and put things away. Alright, so now what were we doing? We were going to make the PCB for okay, I'm just gonna, come on, Eagle, you can do it. So alright, drink time. I bet a significant number of you that are watching this right now have these Arnett drink bottles or have had them in the past. Australia's Academic and Research Network. How many of these have I got? I think I have 4 of these drink bottles. Thanks, Arnett. Yeah. Cable Tie says, but we learned something new. That's a useful squirrel. Yeah. I love learning new stuff. The problem is that I then forget it. But it's, I like learning about new things that I can use to, where will I move that? I'm going to move that off. Let's see. Projects. And it was UT61E Wi-Fi, hardware, this. So this is where we left it last week. And I've done a little bit of thinking about it. Move this over here. Right, manage libraries. Got to do an update. Come on. Alright, so Michael says it's usually Evil Steve's fault that we have Arnett bottles. Yes. Oh, Frank said, you must have the heating on, John. It's bloody freezing in Melbourne today. I had the heating on and I turned it off right before I hit go live on the live stream because it was kind of noisy. I've got a reverse cycle air conditioner here in the lab, and it's mounted up over the window there to my left, blowing just straight out into the room. But the fan noise is fairly loud, and so what am I doing? Superhouse resistors. It's saying that they are not downloaded. What's the deal? Okay. Why does that have a little library unavailable? That's weird. Okay, there's some weird stuff going on. I don't know what's going on with that. Hopefully that's not going to impact what we're doing today. We already have parts on here, and I will resolve my argument with Eagle a little bit later regarding its libraries. Johnny says, you left no place for the antenna on that layout. This keep out in the middle here is to stop the copper pour where the antenna is going to be. So let's just get ourselves a view of this in Fusion as well, and then pull in a D1 Mini into the model, and we can see how it's all going to fit together. Now, there was some time a few months ago, I started trying to do a demo in Eagle of silly tricks with the grid, and setting the grid to strange values and different units to what you normally use. And it was one of those things where I wanted to demonstrate something, and off the top of my head I couldn't figure out a neat way to demonstrate it, but there are things we need to do on this PCB now that are going to involve those very self-same silly tricks. So we may get a chance to play with it. So Johnny said the connector is where the antenna goes. Yes. I think you're right. This is why doing a 3D version of this is very useful. The antenna sticks off the end of the PCB, so we're going to have to make this whole thing longer to clear the connector. For the connector to clear the antenna. So if just while we're waiting for Fusion to open, it's it hasn't got to the splash screen yet. Oh, there we go. We've got to the splash screen. So what I'm going to do is move to the overhead camera while we're waiting for Fusion. Come on, overhead. Oh, it's struggling. OBS is struggling because it's too busy opening Fusion. So looking at the D1 Mini, if it's oriented like this, this is the same orientation as on that Eagle layout. You can see the USB connector is down at this end, the reset button is here, and you can see that the antenna sticks up beyond this portion. So the headers end there, and then there is this distance here, and this, I believe, is what Johnny is talking about. So going back to the computer. Come on, switch. That's it. All right. Coming back to here, you can see that that's the end of the header, that's the back of the other connector, the antenna is going to come right through here and interfere with this connector. So Johnny is absolutely 100% correct. We do not have enough clearance there for it. Scott said, all the more reason to swap it for an ESP12 module. Yes. The reason that I'm doing this with the D1 Mini is that it provides the USB and all of that sort of thing without me having to do anything. Because I'm being kind of lazy about this. This is not something that is going to... I'm not going to be making a lot of these. It's not worth optimizing the design. I want to make this as simple as possible. I just want it to be a carrier board with the connector for the optical interface for the multimeter, D1 Mini on it, and the minimum other parts that we need to make it work. So that it's the sort of thing that can be assembled in 5 minutes. I want to make it easy on myself. Yes. And Cable Tie said, what did I say last week about doing a full footprint for the D1 Mini? Yes! Yes. That would be useful. Now, let's, what am I thinking about? Okay. I'm wanting to get Fusion up and running because then it's easier. I can do hand waves all day long and not really convey what I'm talking about. But if I can pull this into Fusion, I can show you on the screen how things fit together, and we can see clearances and all of that sort of thing. And problems like the clearance of the antenna become super obvious. And Scott said, then turn it 90 degrees. Yes, I think that was mentioned last week as well. But I don't like the idea of things coming out. We're going to have the cable going to the multimeter, and we're going to have USB. I want it to be in line. I don't want it to be at a 90-degree angle because it just becomes awkward. You end up with a thing that is awkward on the bench when the two cables come in at strange directions. If they're directly opposing each other and they're in line, then it makes things easier. Yeah, good point, Johnny, who said using a D1 Mini also saves you from 54 weeks of waiting for the serial chip to show up in stock. Yes. I wonder what my D1 Mini stocks are like. D1 Minis, they're my kind of go-to, oh here it is. They're my kind of go-to little board for these sorts of projects. I've got, yeah, I've got plenty. It's a treasure trove. I've got how many? They're probably like 40 or 50 in there. So I've got a whole box full of D1 Minis. Enough for me for now. Okay, back to here. Switch to desktop. Come on, you can do it. Switch. Switch. Yes. Okay. Zero stick. Yes, that's a different thing entirely, which is cool and interesting, and I could talk about that, but I'm not going to right now. Now, what I was just looking for was, do I have... No, that's right. Resources is where I looked last time. I wonder if I can find... Search all data. D1 Mini. D1 Mini. Do I have one? Maybe. I am sure that I've used D1 Minis in things before. D1. That's a different project. D1 Zig. It'll be annoying if I don't have... Come on, give me the cursor. It'll be annoying if I don't just have a D1 Mini somewhere in my library. Come on, delete. Try to... What is wrong with this? search D1. Let's just do a search for D1. Oh, maybe it hadn't finished. What? How did the number... Oh, because Mini found a match. It must be... Search in Fusion must be a... it must be an OR on the search terms. That's really, really silly. Alright, well, let's go back into... resources, where I have a Raspberry Pi. This is where I would have expected to find something. And let's go to good old GrabCAD. Not GrabCab. Where am I going to end up with that URL? GrabCAD.com. I do not want GrabCab. Oh, GrabCab is for sale. Oh, which reminds me, do any of you want to buy a domain name? Because I own fiberoptics.com, amazingly enough. And I've owned it for a very, very long time. What am I doing? Let's log in. Why not? Yes, sign in. You got to sign in anyway to be able to download anything. So back to library. I've put a few models up on GrabCAD. Once I started making custom things to go in Eagle, I ended up uploading quite a few connectors and different bits and pieces. What am I looking for? D1 Mini. Come on, there's got to be a model of a D1 Mini. Shield, where's a good model? We must D1 Mini Pro. That model would do. D1 Mini. That looks like it would do as well. So what have they given us? Oh, great. Only SolidWorks and JPEGs. That is useless. Come on, at least give us a step file or an IGES or something. Where's a D1 Mini? Oh, here we go. D1 Mini with step. So D1 Mini step. Yes. I want that one, please. Downloaded. Done. Upload. Now this is this is getting into tedious watch John click things territory, which is not particularly fun, I'm sure. Select files, come on. Okay, downloads. Where is the D1 Mini step file? WeMOS step. That'll do. That'll do, donkey. That'll do. And upload. Alright. So now at least we will be able to stick a D1 Mini into our design, and we'll be able to see all the clearances and how everything fits together. Now, I've been thinking more about the types of connectors and how to attach these two boards to each other. So the orientation of, does the D1 Mini go on upside down, or does it go on the normal way? Does it go underneath the other board? Does it go on top? And once we've got this in, oh, complete. Once we've got this in Fusion 360, we'll be able to visualize that a whole lot better. And one thing I've been thinking about is the idea of just having them directly soldered together. It's a pretty horrible model because it doesn't have, because it came in as a step file, we don't have low battery. Oh, I'm gonna have to recharge my my Space Mouse. So it doesn't have textures or materials or anything set on it because it just came in as a step file. But it'll do for all our clearances and things. So what we can do now is go back into, I need to open, where are we, Superhouse, it's pinned at the top, Superhouse modules, and this is where we will have UT61E Wi-Fi, and I am absolutely sure that I have a model of a D1 Mini somewhere in this big concoction of things. Alright, so as Johnny pointed out, there is no clearance here for the D1 Mini's antenna. So let's come back into here, go into resources, and insert this into the current design. Why can't I insert it into the current design? Is that because it's in a different project, as in a different folder? That would be annoying. Let's make a, just in case that is the problem, let's make a copy of it into Superhouse. Why? Yep. Brain not particularly functional today. Back to Superhouse modules. And we should now have D1 Mini in here. Why am I not seeing it? What? Oh, Wemos. There we go. Okay. Now can we do? We can't do insert into current design. I wonder if that is because it is a this is a design that has been synced from Eagle. Alright, let's fix this. I am going to do something a little, okay, what I'm going to do instead is come into new design here, and I'm going to stick in, going the wrong way, and I'm going to insert that into the current design. Please save this design before inserting components. Of course. UT61E Wi-Fi assembly. So what I'm going to do is make an assembly which consists of multiple other things. Saved. And I'm going to insert that into the current design. And I'm going to just accept its location. The 0 point can be, that's not a very nice 0 point. This is all going to move around. Okay, I am going to just accept that 0 point. That's because we made it wider. And I'm going to insert this as well. And this is all just for the purposes of moving stuff around and seeing how it fits. So we'll spin that around there, take it back 90 degrees, take it up a bit. Now I can do all of this with, to do this properly, what I'll do is actually link the things together with joints so that they're all perfectly aligned, but we don't have the right headers in there, we don't have anything yet. This is just shoving things around in 3D space. Come on, computer, what are you doing? So that we can see where things go. And then I'm going to fix it on the PCB, resync, and everything should be alright. Now, while I'm waiting for my computer to figure out that I want to move that part, what have I been missing? In the chat. Just going to move it across here a bit. It's not quite aligned, but this is something that is done on an imperial, with imperial dimensions, and it's on a metric grid right now, so there's no way that it's ever going to be in the right place. But as I said, this is just to give us some idea of where things are going to fit. Ignore those, where are we, board, packages. ignore those for now. Alright, I'm just going to hit OK. Alright, so now we have the board, and as Johnny pointed out, there's no room for the antenna because it goes through the back of that connector. If it sits right there, it's not going to work. So, yeah, this is one of the reasons that I do like messing around with these sorts of things in a 3D view as well, not just in a PCB view. And as Cable Tie said, if we'd made a footprint for this complete object that included the mechanical dimensions, then when we put it down on the PCB, it would be really obvious that we can't protrude into that area with the connector here. Yes, that would have been a proper way to do it. Now, I'm just, my mind is all over the place at the moment. I'm not even really thinking about what I'm doing properly. Okay, so let's get back into this little area here. No, first, I do want to look at this, because what I want to think about is where the parts are going to go. So you can see here we've got the MOSFET and a couple of resistors that are sitting on the top of this PCB, and then the D1 Mini is going to fit on top of it. This is actually the whole point of why I wanted to do this model. What I've been thinking about is soldering the D1 Mini straight onto the carrier board using pin headers without using a socket. So the two of them just become permanently attached and you can't take them apart again. And that means that the whole thing will be thinner and it won't stick up too much, because if we have, where were they? These things. So if we have that as the height of the headers that would go on here, and then let's move this. Move. So if we now move this, imagine this had pin headers underneath it. Those pin headers have a plastic spacer that's about 2.54 millimeters thick. So what would happen is that it would sit at about this height, maybe even a little bit higher. So the gap between the top of that header and the bottom of this PCB would be about 2.5 millimeters. So let's take this up. It's probably somewhere around there. It'll be in about that region. So what would end up happening is that the D1 Mini is going to sit up high like that. It's going to be significantly higher than... in fact, the funny thing is that would make it clear. Oh, I think I might have just changed my mind about this. So what I had been thinking was to make the carrier PCB longer and to attach this directly with pin headers so that it was much lower and make the whole thing low profile. But the interesting thing is that if it's up at that height, now we've got clearance. It can sit over this connector, which means I can use pin headers on that, and I can use a socket on this, or vice versa, which means the D1 Mini could be upside down. I'm kind of it means that it is removable. Okay, things have been going through my head which I have not really conveyed to you very well or at all. Where I was thinking of going, alright, I'm going to follow this through logically so that you can understand why I was saying it. I'm going to get rid of these two headers and I'm going to move the D1 Mini. Yeah, Chip made a comment about putting it on the bottom. Yes, so that ties into all of this as well. Now imagine that we had pin headers in between, and what you would do is you'd put the pin headers in and solder them onto the carrier board. Then there is a plastic spacer, and then what I would probably do is get a second plastic spacer and shove it onto the pin headers, so you end up with a 5mm gap instead of a 2.5mm gap, and then solder this directly onto it, so the two PCBs become permanently attached to each other. And it would end up somewhere in this region. Where's I don't even know, what's the distance between that and that? It is 5.03mm. Hey, I eyeballed it almost perfectly. So basically it would end up there. Ignore the fact that we're intersecting the connector for now. But those two PCBs would end up about 5mm apart, or 5.08mm I think technically, and they would be soldered together. And what that means is, see these little parts under here? You can't get to them anymore. They are totally inaccessible, and if anything goes wrong, not that anything should go wrong, it's just impossible to do any rework or anything like that. So this comes down to what Chip was talking about with why not put it on the bottom. And what I had in mind was maybe conceptually reversing all of this so that these parts are on the bottom here, and then this is soldered directly on with the pin headers, and that way, if anything, you can rework the parts that are on the carrier board, so without having to get anything apart. The what's on this face of the PCB, it'll just be blank. It'll be like the bottom of the PCB. So you could consider it conceptually, it'll be upside down like this. What it would be like is this is the top of the carrier PCB, and this would have the transistor and the resistors sitting on this side of the board. So, reorient yourselves. We're standing on our heads now, and imagine that this is the top of the PCB. The connector, the DB9 connector is on the bottom of the PCB, and the D1 Mini is underneath. So this is actually much more like what you would think of as like an Arduino and a shield on top. So in this case we've got the D1 Mini underneath, and then a shield on top, which is the adapter board. Even though it looks kind of weird because we've got the connector upside down here, this is conceptually much more like how you would normally think of this sort of thing. It's the microcontroller underneath, the adapter board on top. It's just that the adapter board happens to overhang, and it's got a connector stuck on the bottom of it just to use up that cavity and to stop the whole thing from being too high. So, Scott says pin header spaces are only 2.6mm. Yeah, or 2.54 I think, because they're 0.1 inch. But what I would do is put two of them on. So I've actually done this many times, and it works really well. What I do is, I'm going to switch to overhead camera. In fact, I might even have to switch to the microscope. I'm going to turn the microscope on in anticipation. Let me see if I can find, so this is my little local cache of pin headers. Oh, look at this. You can see here, maybe you can't see here, that is a plastic strip that of a pin header strip that doesn't have any pins in it. And that's because I've pulled pins out and used them for other purposes, and I keep these strips. So, and here is an 8-way pin header, here's another 8-way pin header. This is what I would do. Let me get some microscope action happening. And where are we? Is that even working? Yes, it is working. Okay. But I need far less zoom. I need more like, which way to focus? It's getting worse, not better. Keep going, keep going, keep going. Okay, now we've got some kind of focus, sort of. So this is the plastic strip out of a pin header, and I do this fairly often. What I do is just cut off bits of the pin header and then stuff it over an existing pin header like that, and now we've got a double height pin header, and put one on the other end just for a bit of consistency. So now we've got a pin header that has 5 millimeters gap, and just one plastic strip is not generally enough. If you've got two PCBs and you want to sandwich them together, if you just use a thing like this and you put one PCB on each side and then just solder them, that 2.5 millimeter gap is generally not enough to have components on the two boards, particularly if you've got things like 0805 capacitors or modules or whatever. So yeah, I do this trick often when I'm trying to sandwich two PCBs together and have enough room in between. So that way you can have things like the USB connector. So if we come back to the desktop view here, so right now the gap in between these two boards is 5 millimeters, like 5.03 or whatever in this model, which represents that spacing would give us that, and that gives us room for things like the USB connector and any other parts that we might want to put in there. Cable Tie says, sandwich your PCBs with this one weird trick. Yeah. When you're getting pin headers from factories in China, if you're getting them done in bulk, you can actually get them done to custom lengths with custom numbers of plastic spaces on them. In fact, I'm going to find you an example, because this is actually where I didn't even know this. I've heard about this from Mark, who did the board design on this for Freetronics. And I've got to think about where would I have one? I think I have one no, I know where I have one. I know exactly where, but I have to leave the room to get it. So please enjoy this intermission. And intermission is over. And I'm just hoping that what I'm pulling out here does. Yes, it does. Check this out. This is really cool. Hang on. I'll clear myself some space first. And go to overhead. So this is an LCD shield. And there are multiple clever things about this design. That it needs to sit down on top of an Arduino, and so you can see that the LCD is mounted from the back of the PCB. It's actually coming through a cutout, so it's bolted together. The two PCBs are sandwiched hard against each other, and the LCD sticks through a slot in the front PCB. You can see that there's a green PCB for the display, blue PCB for the shield. But the whole point of showing you this is look at these headers. These are pin headers, and if I get the light at just the right angle, you can see that there are 4 rows of plastic spaces on them, and then the pins protrude past there. So the actual length of those, I can't remember what they are, 18.8 millimeters. So the pins are 18.95, whatever. It's there's solder and stuff that's messing it up, but about 18.8 millimeters is the total length of the pins, and then there is basically 10 millimeters of plastic spaces on it, because there are 4 rows of plastic spaces. So with the production of these shields, what we do is go to the factory that makes the pin headers and just say, we want pin headers that are 18.8 millimeters long with 4 rows of plastic on them. And we want, 10,000 of them or 1,000 of them or whatever the quantity is. and they produce them like that. And then that allows you to plug it into a regular header, like an Arduino header, and have clearance for all of this stuff which is on the bottom of the PCB. So this was actually the first time I saw this done, and it was because Mark very cleverly specified this. I didn't even know that you could specify pin headers in arbitrary amounts of stacking and lengths and things, but he did it, and that was all very cool. Yeah. Yes, yeah. Stephen said, I have had a 40-pin Raspberry Pi pin header with spaces to make it sit 20 millimeters off the board upside down with 20 millimeter standoffs to screw into. Yep, cool. Yeah, since then I've seen it with Raspberry Pi headers as well. And the other place that so after seeing that, I then did it actually in the ArduSat. So ArduSat is even more complicated. It's stacking headers with additional spaces in order to give it now where, yes, I'm going to grab one of those because these are cool. Also, it's another intermission time. Now these were custom made for me in a factory in China as well, to suit the CubeSat specifications, because this is the stacking CubeSat bus header. So CubeSats commonly use the PC104 industrial computer bus specification, and this is a header that suits that. And the specific header that is that's mentioned in the CubeSat specification is very expensive. So I talked to a factory in China and said, can you make me some custom headers? And this is what they made me. So it's I can't even remember how many pins it is now. It's whatever is used in the PC104 specification. They're stacking headers, so the pins come all the way down, and you can see that there is an extra row of plastic spacing below the body, so that when this goes into a PCB, the top part protrudes further than a normal stacking header would, and there is enough length in the pin section here that it still protrudes down the correct amount once it's in the PCB. And yeah, so if you're doing things in any sort of reasonable quantity, it is quite feasible to go to the factories that make things that are off the shelf. Things like pin headers that you would normally think they're all the same, they're standard, everybody makes them the same. But if you can find the factory that makes them and say, give me a pin header that is stacking and it's 2 by 40 or whatever it is, and I want extra spaces in here and I want to specify the pin length, they can do it for you. Or, you know, bizarro pin headers like that. It's all possible. You just have to know that it is possible. So, Dodgy said, please straighten out the pin on the left. Which pin? Is this a bit of OCD kicking in? Which pin is that? The pin on the left. Ah, you're right, that one right there. Maybe I should leave this on the screen just like this, just to drive Dodgy a little bit bonkers. But no, I won't do that. I understand that frustration. I feel that myself. I know what you mean. So I'm going to fix that. So a bit of precision pin alignment here. The one next to it has been slightly bent as well. So we'll adjust all of those and get them into a nice precise rows. Hopefully that makes everything feel calmer and the rage is subsiding. Okay. So Johnny says CDO, yes. where the letters are in order as God intended. So Station 240 says, any tips for finding out who the original supplier is? The original supplier of what? I don't know what that what that's referring to. Original supplier of the CubeSat headers? Yeah, don't know. Okay, so here we are back here. We're at 11:30. We don't have much time to finish this. At least we can make some decisions. I think we got half an hour. I think we can kind of sort out what we want to do with this in the meantime. All right, so now, so the decision is, now back to what Longflare was saying earlier with putting the D1 Mini underneath. Yeah, so conceptually, it could be underneath like this. And in that situation, what I would actually do is flip the I would flip the D1 Mini 180 degrees so that it is in the correct orientation. So the normal orientation for D1 Mini is with the reset button on the left. So like that. If we were looking at this equivalent to an Arduino, it would be kind of like that. Although normally an Arduino has no, this is the usual orientation. If you look at pinout diagrams of a D1 Mini, this is how they show it, with the reset button in the bottom left. So this would be considered to be the top, and then other things plug in on top of this. And if we go back to our model, you can see that we actually have this backwards at the moment. Because I just spun this to talk about this conceptually, that is the way that it should be. Now, how to fix this? Alright, I think that I'm coming around to the idea of... Oh, no, but I'm totally thrown now. Okay, so this is the tangent that I was going on. Was this, what I'm showing you now, is what was in my head for how this would all fit together, but with the moving it out a little bit, making it a little bit longer so that this would clear. So I would double stack the plastic on the pin headers, solder it directly on, and then we would end up with this nice little low profile thing, and I would move it along. But now the idea of making it thicker and overlapping it has kind of thrown me, and I like that idea a little bit more. It's going to end up thicker but shorter. So if we come back to it being oriented like this, however, it is still what I would consider upside down, because the connections under the D1 Mini. So I think no matter what, whether this goes on connected with pin headers with narrow spacing, or connected with headers and overlapping with the DB9 connector, in either case, I think we're going to have to mirror the whole thing. So I think that is our starting point. That's the next step that we need to do. Jack's Tech said, flip the DB9 and other components, saves fixing the silkscreen. Yes. However, I'm thinking about that. Yeah, I kind of considered that as well. But the problem is that from Eagle's point of view, that means that the parts will be on the bottom layer. Now, part of this is me kind of being pedantic, and what it would mean is that, of course, I'm going to be hand assembling a couple of these, so it doesn't matter. But I'm thinking about this from the point of view of, if this was a more complicated project and we wanted to run this through a pick and place machine, we wanted to assemble a few of them, ideally what we want is for the parts to be only on the top side and none on the bottom side. Now, yes, it makes no, as long as you've got them only on one side, it makes no difference. You can say just assemble the bottom, but it is an extra complication. It is something where things could go wrong potentially. And the convention with single-sided boards is that the parts go on layer 1. So I don't want to put the parts on the bottom layer and have no parts on the top layer, even though mechanically and electrically it would be 100% correct. So, Jax, I do agree with what you're saying. I know what you're getting at there. But I'm going instead. Okay, let's do one weird trick thing and do some messing around with grids and stuff inside Eagle. Now, the reason... Now, which one do I want? I think I want the sockets on... I want the socket to be on the D1 Mini, and I want pin headers on the carrier board. So things are a little bit different anyway. So let's have a look at this. What have we got here? We have, this one is my 1x8 header with, I can't remember. It's the one with the socket on the top of the PCB. And what I want is pins on the bottom of the PCB, but I also want to mirror everything. Alright, just logically thinking through this. I think there are a couple of steps to this. The first step is to put the parts that I actually want on there. Then I'm going to mirror the geometry of the PCB, and that's going to involve a little bit of messing around with the grid, which is cool because it lets me demonstrate that little one weird trick thing. So I'm going to add a part, and we're going to add some pin headers to replace the other headers. Now normally I would do this by just doing a part replacement, not by adding a part and then deleting the original part. Because we're doing a 1-for-1 swap, it's an 8-pin header being replaced with an 8-pin header, you should be able to just go part replace and have it match all the pins up and everything work. But there is a problem with that in this specific case, and I'm going to show you why in just a moment. Now, what am I looking for? Superhouse connectors, and I want an M08, and I want it with pins. The reason I got multiple things here is that I've got, so a 1x8 header, I've got it as a version with pins that stick up above the PCB. There's a version with pins below the PCB. There's a plain one with nothing in it. There's a one with a socket like you can see there on the screen. There is one with a stacking header. And electrically they're identical. The pads are identical. The only difference is that I've got multiple parts in Eagle for this so that I can match all these different 3D models to it, and that just helps with the visualization when you pull it into Fusion. So I want the 1x8 pins below the PCB, and if I stick that on there, and I'm going to stick another one over there, and I want to have, I'm going to make it match that. In fact, what I should do is delete that and that so I don't confuse myself, and I'm going to put that one, let's just put it here for now, mirror it so it's got the correct alignment. Okay, so what we have is the header that is here. So this is the existing 1x8 header, which is just the plain one, and I want to replace it with this pin header, which is going to have direct, so pin 1 is going to be reset, pin 2 is going to be A0, etc. It's going to be exactly the same, but I want to, now the reason that I couldn't just do a part replacement is, if you look at this one, you'll see that the anchor is around pin 4, right there, and the anchor on this one is behind pin 1. Now this is partly, and in fact there's a corresponding thing. If we go into the physical model here, and move stuff around. I don't know which one's which, but it doesn't really matter for now. We'll look at that in just a second. Now, this one on the right, oh, it's locked. Let's unlock it. This one on the right is the header that is on this existing design, and you can see that the origin, the anchor, is right in the center of pin 1. Now if you look at this new one, the one on the left is the new one that I've just added. This is the one with the model of the pin headers below, and you can see that the origin is right in the center. It's between pins 4 and 5. In fact, that needs to be spun 180 to make pins 1 and 1 match up. I don't even know if this is the right one. We'll figure that out in a moment. Now, this is because of a change that I made. So this board that we copied here, this was done in 2017, and since then I've made major changes to the way that I do my parts in Eagle, and I've changed the point of origin to always be the mechanical center of the part, and rather than pin 1. So a lot of models you'll see have the point of origin as being pin 1. And what I found when doing pick and place is that with pin headers, I don't pick and place them anyway. I always just solder them in. But this is just the general concept is what I'm explaining. What you care about from a pick and place perspective is the center of mass of the part, or to be more pedantic about it, the center of a flat surface on which you can get a vacuum suction. So if your pick and place head is grabbing the part to take it out of the tape or out of whatever the feeder is and put it down on your PCB, you care about having a part on that. So for example, if you have, well, say you were pick and placing a, this is actually a good example. Let's have a look at this D1 Mini. This D1 Mini has an ESP12 module on it, which has a big metal can. Now, if you were pick and placing this ESP12 module to put it onto this PCB, you need to be able to pick it up from somewhere. And it's got this metal can, which is going to be the obvious place to do it, but it's not in the center of the object, it's slightly offset. So the optimal place to pick this up is going to depend on the size of the nozzle, which in the case of a big module like this is going to be a large nozzle on the pick and place machine. You can't have that nozzle overlap the edge of the metal can, or you're not going to get a vacuum seal. The entire diameter of the nozzle has to be placed over a flat surface. So you have to keep in consideration, what size nozzle is the pick and place machine going to be running? Where do I need to make my pickup point so that that doesn't overlap any non-flat surfaces? And you want it to be as close to the center of mass as possible, so that as the pick and place machine picks it up and moves it around, if it rotates it, you don't get the effect where the part slides sideways because its center of mass is not aligned with the center of rotation of the nozzle. Anyway, this is squirrel chasing, but that's what we do here. So anyway, all of this, the reasoning behind this, and needing to be able to pick parts up reliably in a pick and place machine is why I've been rethinking how I designate the center point or the origin point of all of the parts in my library. So I like consistency because I have COD or whatever. Because I have CDO. What I like to do is have simple rules for myself, so that if something is done in a certain way, then it is done that same way everywhere. And I don't want to be thinking about, oh, do I do it from pin 1 in this particular situation, or do I do it from the center of mass, or do I, in the case of the schematic, do I have the pickup point always on pin 1, or do I have it near the center? So the way I used to have things set up was that the point of origin for things in the schematic was in the center or close to the center, which means that if you pick it up and you spin it, it stays in the same place, essentially, like or close to the same place. It just rotates on the spot because the center of rotation is the origin point, which is in the middle. And in fact, a good example of that is right over here. Look at this connector. We've got this here. The origin is dead center. And if I just select that, and then if I just right click, it's just going to spin on the spot. You can see that the cursor isn't moving. It's just moving around that center point, and I can just put it down again. With this one, I've got the origin behind pin 1, and if I spin that, so I'm just going to leave that still and right click to make it spin, you can see that it's going around, and it's going up above and then to the left and then to below and then to the right. So it's spinning on that point behind pin 1. And anyway, what I used to do, and the problem is, look how hard it is to find the origin on this part. It's obscured by the other parts of that part. So anyway, what I ended up doing was I decided to settle on making the origin of my schematic parts adjacent to pin 1 so that I could find it, basically. So every, well, in the case of a transistor, it's in, like something like this is different. That's in the center. Oops, you can't quite see it. Right there. The origin is in the dead center of the transistor. The origin is in the center of the resistor, so I don't have it pin 1 in that case. But what I decided to do was, for my connectors at least, I would make the origin of the schematic symbol adjacent to pin 1 so that I could always find it. The other reason for doing that is, imagine I wanted to do a part swap. Now, this is actually something that that happens quite frequently. If, say, I've got an 8-pin header here. In fact, I'm just going to duplicate this one because it's going to make it super obvious what's going on. And maybe you've got some nets coming off it. So you've got nets connected to pins 1 to 8. And now you realize, hang on, I want to change that to be a 10-pin connector. So I'm going to go down to Replace, and I'm going to select a 10-pin connector, and it's going to be the 10-pin version with pins below. So it's the same as what I've got there, except that now it's 10 pins. All I have to do is click on the origin, and boom, now I've got a 10-pin version. Pin 1 hasn't moved. Pin 2 hasn't moved, so pins 1 to 8 are still in the same position. They can still be connected to the same nets. You don't get that weird skew thing where you've moved apart and now all of your nets are messed up. It's just added 2 pins on the end. And I find that this is a really neat way to work with stuff in schematics. So having everything in schematics anchored to pin 1 as being the point of origin, I find really, really useful. But in fact, but here, so this is the, let's move that, but this is the 10-pin thing that we've just created. But for the parts that go on the PCB, I make the origin the center of mass. Anyway, I've probably lost you all because I've just been talking about a totally irrelevant thing for way too long. Okay, now, what were we doing? Back to here. Okay, let's have a look at the schematic. Get rid of this. I want to get the basic mechanical sorted. We've got 15 minutes. I want to get the basic mechanical sorted anyway. Alright, so this is where the little grid thing comes in. What I want to do is take this pin header and replace it with this pin header. And, you know, why is that grid? What's going on with this grid thing here? Is this off grid? It is. That's nasty. Look at this, it's at 1.35. I'm going to make that 1.3. That, I don't know how it ended up there. It really shouldn't have, because things should, on the grid, on the schematic, should always end up on a 0.1 grid. So yeah, that must have been copied from something somewhere ages ago. So I want to replace this part with this part. So pin 1 connects to pin 1, pin 2 connects to pin 2, etc. That's easy to do in the schematic. But now if we come across to here, in fact, I just want to highlight it so I know whether I'm looking at the right one. Okay, highlight that part. Come on, there, okay, it is the right one. So yeah, so pin 1 is going to become reset, and you can see reset is here. But I want to put it into the exact same position as this one because I need the pins to align with the D1 Mini. So how to achieve that? Well, what we've got here is a position of, it's a strange position. It'll be it's a metric multiple. No, not a metric. It's an imperial value. So 1.27 millimeters is 0.05 of an inch converted to metric. And I want to make the position of this one exactly match the position of this one. And this is where funky grids come in. So let's do this. I'm going to set the origin of y. So the y value here is 26.67 millimeters. I'm going to set the origin of this one to exactly the same, 26.67 millimeters. So now you can see that we've got the two connectors that are offset. And we've got the original one here with its origin on pin 1, and we've got the other one with its origin in the center, and it needs to be offset so that it goes into the correct place here, the correct vertical alignment to match the other one. Now this is where this is where you could just do a bit of quick maths and type the value in and solve the problem. This is not the best example because we do still have to do maths because of this offset. But alright, pull out the trusty calculator. The thing is that most of the time this actually avoids you having to use a calculator. But in this case we don't. What I want to do is figure out how much distance there is between the offset, the vertical offset of where it is now versus where it should be. And oh, in fact, I can do this. No, I can do this without the calculator. All right, now we are on a metric grid, and I want to move it down so that it is aligned, but we need to move it by a certain number of half multiples of the spacing of this connector. So this connector is a 0.1 inch header, so 2.54 millimeters. Forget millimeters for now. We're going to go into like shekels and barrels and furlongs and stuff for a little while and talk about imperial measurements. So we want to move it down to make it align exactly. Normally you would have to mess around with conversions and calculations and things here. This is the trick. What you do is go into grid, change it to inch. I'm going to change it to 0.05 of an inch because that is half of the space between these pins. So that now is on a 0.05 inch offset from the center of a pad, and that is on the center of a pad, which means if I now simply grab this and drag it, I can drag it down there, boom, it is now perfectly 100% aligned in the y-axis with the other connector. No calculator required, didn't even have to think about it, just did it. So now what I can do is go back to my normal millimeter. I'll go back to a 1 millimeter grid, and we've got our offset fixed. So now what we can do to make it align vertically, because we want to basically just sit at one on top of the other, the Y has to be offset by that amount, but the X has to be the same. So what I can do is just take, okay, we've got 1.27 millimeters there. I'm going to click on this one, make that 1.27 millimeters, and boom, we now have two connectors that are perfectly corresponding, even though we are on a metric grid, and those connectors have their origins offset by an imperial distance compared to the relative to the spacing between the pins. My words were horrible then. My explanation made no sense. All right, let's just do the same thing over here. So I'm going to spin this one around, and I am going to give it the same origin point. So it is, oh, this one's locked. Let's, oops, no, not, I clicked the wrong thing. Pop, locked, 26.67. So I want to set the origin of this one at 26.67, and then I'm going to go over here to my grid, go to 19th century units, and I can now just drag this down. We have perfect alignment, and then I can switch my grid back to sanity, and I can find out what my X offset is here. It is 24.13, and I can come in here and go 24.13. Boom, we have perfectly aligned parts. So anyway, my point with that is was to say that you can, by manipulating the grid and changing between different units, you can avoid a whole lot of calculations. You can avoid a whole lot of those multiply by 0.254, you know, things, and save getting the calculator out when you're wanting to take imperial spaced parts and align them perfectly using onto metric grid and vice versa. So there is a variation on that trick that we will use in just a moment, which is, one thing I really like to do is set the grid to an unusual size, which is the exact offset that I want to move something. We will see that in just a moment, but first let's fix this in the schematic. What I'm going to do is come in here and just go delete, and then I'm going to grab this other connector, move it so that it's in the same place. Now it's connected to those same nets. Then come over this side, and I want to delete, where is the origin? There it is. See, this is exactly my problem, finding the origin. So grab that, take this part, snap it into place. So now we've replaced those two parts with the models that have the pins underneath. And if we come through to here, so let's save that. Go back to Fusion 360. I'm going to close this project because I don't want it to block me doing any updates. And come back to Eagle, push to Fusion, and now we should have pin headers underneath. Push. Which are going to be on the wrong side of the PCB, and then we're going to have to do a mirror thing, which is where that little grid manipulation trick. Daniel says you could also just lay out the board in inches. No. Yeah. So let's measure these things in Whitworth. What is Whitworth as a unit of measure? I have a bunch of Whitworth hardware in the workshop. What is Whitworth? I haven't heard of that. Peter says, I had the board in parsecs per second. We would be, yeah, I'm trying to think about what that unit would be. Because a parsec is an incredibly big unit. A second is very small. We'd be dealing with lots of decimal points. Well, with a lot of offsets from the decimal. All right, so that's pushed to Vision 360. So let's just refresh and we will see what changes in our design. Now I'm going to do it says a component is out of date, so I've just clicked that to update it. It's going to pull in the updated version of the component. So we'll now have the board, and as you can see, it has the pins underneath, which is what I was kind of getting towards. So now what we can do is move the so now we can move the D1 Mini down and we can invert the connector here and everything should align nicely. So if I go to D1 Mini, I want to select that and move it, and I'm going to drag it down, straight down. So I'm going to bring it down here. Now once that D1 Mini has sockets mounted on it, it's going to fit somewhere around about here-ish. Anyway, that can all be fixed later. That'll do for now. And then once this connector is inverted, it should fit into this space here. And everything should be hunky-dory. Alright. Now, okay, what I'm going to do is fix the offset. Alright. Here we go. Because, now you probably remember from last week, this project that I copied it from was the width of a D1 Mini. It came to about here, and I had to make the PCB wider to accommodate this DB9 connector. Now I've been seeing people talking about screw holes and things in here, and yes, we should probably fit some screw holes in somewhere so that we can make a little 3D printed enclosure that clamshells around it and screws closed. So there's going to need to be room for screws. Maybe notches out of the side would be helpful, or a hole in here. I'm not quite sure. We'll have to think about that, but we can get the basic layout done now anyway. Alright, so this is the thing. Now, because I dragged these sides out wider, if we look at the origin, look at this. The origin is here, and that is the width of what this used to be. And then we dragged it out wider. Now this is currently at, it'll be minus 3 millimeters, I think. Yes, it's minus 3 millimeters. So this is going to be a kind of silly demonstration of what I'm talking about, but this is just to illustrate what I mean about setting the grid to something unusual to suit what you need. Now, if this had been from, in many cases, this value isn't as nice. Now here we need to move this whole project to the right by 3 millimeters because I want to put the origin to be right there where my crosshairs are. I want X and Y to be 0 on those edges, just because. So the positions of all of the parts are set relative to the point of origin, and I want the X and Y values to be correct from that 0 point. Once again, it's just like it's a pick and place thing. I want the coordinates of the parts. There shouldn't be any parts with negative coordinates and things. That's annoying. So what I do in this case is I go into the grid and I'm going to set the grid to 3 millimeters. And that's because I want to move it to the right by 3 millimeters. So if in fact, let's just make sure I've got all the layers turned on. B place and T place, they're they're the critical ones. Got all the origins turned on, other stuff. T-finish, glue, keep out. Let's turn everything on, turn all those on, because we want to move them all together. And now I can select that and go to move group. And now when I move this, it is going to move exact multiples of 3 millimeters. So that is where it was before. I move it I'll move it one grid element to the right, and boom, it snaps into place, and now it is perfectly on the origin. And so that would have been trivially easy to do. I didn't need to change the grid to do that. I changed it to 3 millimeters instead of 1 millimeter. I could have just grabbed it, dragged it across 3 millimeters, put it down, and we would have been done. But what I was trying to illustrate was that sometimes you end up with a situation where you need to move something by a certain amount, or you need to move a group of things. This is where it's really useful. If you've got a whole group of stuff, you want to select it together and move it by some unusual amount, which might be an imperial measurement converted to metric or whatever. What you can do is just change your grid to be the exact amount that you want to move it, in whatever units you want to move it. Select it all, drag it, it snaps into place, and then just set your grid back again. And everything will be spot on. So, yeah, maybe something useful. It might help you in the future. It was one of those things where I got over the idea of, like, I used to set the grid in the early days, and I used to do all of my designs in Imperial, of course, because that's just the way it was done. And so the usual thing was that my grid was typically, I would often work in a multiple or a fraction of 0.1 of an inch, because that's what everything comes in. And so I would start the basic board design. I would put my grid into 0.1 inch and draw the outlines, and everything was a multiple of a 0.1 of an inch. And then I kind of wouldn't change things. And over recent years, I've become much more flexible with using the grid and customizing it. So I'm often either changing the units, changing the grid size to unusual amounts, which might be a specific offset of something, and then moving things around and then changing the grid back again. So yeah, you don't have to stick with one grid size, or even with one set of units. You can change units all backwards and forwards as you go through the project, and it really helps you get things in the right place. So now we have the offset here from that edge. And now Daniel says 0.1 inch header rolls off the tongue much better than 2.54 millimeter header. It does, and I call them 0.1 inch headers because kind of that is what they are. They were designed as 0.1 inch, even though manufacturing has pretty much entirely moved to metric. Originally it was designed as 0.1 inch. Now, what to do next? We're past 12 o'clock. Now, alright, let's press on for just a fraction. I am going to mirror this connector. So that's now mirrored. And let's push this to fusion again. I at least want to get this to the point where the basic shape is there. And even I could spend ages messing around with optimizing the silk screen and doing all those sorts of things. I spend so much time doing that. It's always the, what's that saying? 80% of the job takes 80% of the time, and then the remaining 20% of the job takes the other 80% of the time. It's the last little bits, messing around with silkscreen and getting all the labels in the right place, things that I can just sit here and fiddle with that for hours. It takes ages. So, come on. You can do it. Chris says decimal and imperial, pick a lane. No, I don't want to pick a lane. Actually, I have picked a lane, and the lane is metric. But, oh, I see, decimal and imperial. Yes, because imperial is often, you know, like 1/16 of an inch and things like, why? Yeah. Sorry, Chris, I get it now. I think I misunderstood your comment at first. All right, so now let's refresh the components on here. So what we should now have is the connector mirrored on the bottom of the PCB. The offset is going to be wrong as well because our origin has now changed, which means that our D1 Mini is no longer aligned with the parts. Oh, hang on. I mirrored the wrong connector. You know what? There are actually two connectors on there. If I go back to Eagle, look at this. This is because I was messing around last week and I put two connectors in the same place. And one is on the top of the board and one is on the bottom of the board. So which one is which? Hang on, I'm gonna hide B origin so that I cannot see the connector that I've already mirrored, and then I'm going to mirror the connector that I haven't mirrored. There. Oh, hang on. What? I'm making things hard for myself here because I've got mirror. I think that's it. All right, we should be right now. So I'm going to push that to Fusion again. Yeah, I'm making this hard for myself because I was trying to take a shortcut last week and I didn't have a 3D model of the specific DB9 connector that we want. So I used the opposite gender and I've got two footprints sitting physically in the same place on the PCB just to make the model look approximately right. So that is something that I really need to fix, because it's dodgy having two footprints in the same place and it's going to look stupid in the schematic. But what that means is when I mirrored it, I mirrored the footprint that didn't have a model and I didn't mirror the footprint that does have a model. Peter says, what's for lunch, John? Peter is the lunch police. Thank you, Peter, for reminding me that I need to eat. And it's probably because you need to eat. So you're saying, John, go and eat. Get off the live stream. Update, come on, mirror. There we go. So now we have the, see, we've got parts on the top of the PCB, we've got the connector on the bottom of the PCB, and we've got the D1 Mini sitting underneath it. So the D1 Mini is sitting oriented the way that it should. Oh, except that the offset is wrong. Okay, let's select that D1 Mini and move it. And we wanted to move it. We can actually move this an exact amount. We want to move it by 3 millimeters, which does not look right. No, it's not quite aligned. Anyway, I'm not too concerned about that at the moment. The idea is just to check. Now, one thing I am a little worried about is clearance right here, because what I need to do is pull in the model for the headers. I have a feeling that this is not going to clear. The distance, in fact, let's measure this. This will be about the last thing we do before I go and get some lunch so that Peter can also go and get some lunch. I'm going to get the distance between that face, come on, zoom in, between that face of the header and the PCB right here. What is that distance? It is 10.3 millimeters. That is not the height of a typical stacking header or like a pin header body. So if I grab my little header container, I think it's normally about 8 or 8.8 millimeters. If I put, okay, if that header is what goes onto the D1 Mini, and that is what is going to be plugged into the, so the shield is going to be sitting on top of it. What we care about is that distance there, 8.4 millimeters. So at the moment, in the model, it is 10.3. Jumping back to here, it is 10.3. You can see it, the little dimension is over here, 10.33 millimeters, which means I need to raise that by, let's see, 10.33 minus 8.4 equals 1.93. So let's do this. That and move. I want to move it up by 1.93 millimeters, and I think we're going to have a collision. And we do. Look at that. We have a collision. All right. What this means is that I'm kind of inclined to go back to extending the PCB so that this fits in behind the connector. I'm disappointed because I wanted, I thought it would be really nice. And in fact, the only reason that it doesn't clear is because the D1 Mini is up this way and the module has this. Now the thing is that there are other models of D1 Mini as well that don't have this ESP12 module on it. But the thing is that some of them have antennas on there, like some of them, like the D1 Mini Pro has a chip antenna, which I think sits right in that location, which is physically thick as well. So that would also have a clearance problem. So to be on the safe side, where we don't really know how, I'm spending way too much time messing around with this. I think to be on the safe side, I'm going to make the PCB longer. I'm going to drag this end up, move the connector along so that the back of the connector clears the end of the D1 Mini. And that way it doesn't matter. You can either solder it directly on with pin headers with double stacked plastic, or you can use a socket and a pin header, and you can have different versions of D1 Mini. You could even have like one of the Mini Kit 32s, which is the version of the D1 Mini with an ESP32 on it, which is a bit wider, and it would still fit. So I think that what we're going to do is leave it here for today. Station 240 says, Scott Miller says, flip it. I think we would still have issues because there are still versions of the D1 Mini that have parts down in this area that if we flipped it, it would then protrude into here. So I don't think flipping it is going to solve the problem. Yeah. Cable tie says, for the sake of a few millimeters, extend the PCB. Yes. This is the thing, is that I could spend ages trying to optimize this and it doesn't matter. Like, who cares if the PCB is a few millimeters longer? It's all fine. I wonder how much we do have to move it by. All right. I said earlier that that was the last thing I was going to do, but let's move it by 3 millimeters. And I'm going to turn on B origins again, and I've got to do a rip up to get rid of that. Let's select all of this, go for a move. Where are we? Move group, yes. So it was there, and I want to go 3 millimeters that way. Boom. And push that to fusion. Push, push, push. All right. Oh, okay. Johnny said I won, but I don't know what that's in relation to. I've missed so much in this chat. Peter is still saying lunchtime. All right. Okay. I'm not going to do any more on this. I'm just going to see how this looks in Fusion now, and then I'm going to have lunch. And you should too if you're in my time zone. Pushed. Thank you. Back to Eagle. Update components. And now we hopefully will have the connector far enough ahead that it will clear the back. Oh, I didn't quite move it enough. I need to move it another millimeter. I was just eyeballing that dimension. Anyway, I'm going to stop now because I could keep doing just one more thing and we would be here till mid-afternoon. Yes. Oh, Jack's Tech said lunch just got delivered in quarantine. It's definitely lunchtime. And Daniel said it's always just one more thing. Yes. Cool. So I'm going to stop, or I'm going to keep fiddling with this forever. Anyway, I hope you had fun. Thank you for the distraction and hanging out with me on a Sunday morning. It's now Sunday afternoon. I've got to put a few things away here. I'll clean up later. I'm going to go and eat first. I need to. So I will see you all later, and I will try to be in Discord a little bit more. I recently, that thing, because I've been absent from Discord, I haven't seen all of the activity that's been going on with the light switch controller firmware. And last night I jumped on and had a quick chat to Ben, and he told me about the USM alternative firmware. So I pulled that down and I've loaded that on my light switch controller, which is the one with the fancy, so the that's the firmware with the fancy stuff in it for the OLED and everything, and the embedded library. I have not got the OLED working properly with that, but the other parts of it seem to work, like it's reporting button events and all of that sort of thing. So that's cool. So thank you very much to all the people that have been working on the firmware for that project in the last few weeks. It's yeah, there's been really cool development on that, and I like it. I like it a lot. And I'm going to be experimenting with it, and I've pulled those changes into my own copy of the repo, and I think the USM firmware is probably going to be the one that I will play with in future. So I will see you all on Discord, hopefully, and maybe soon back on video. So thank you, goodbye, have a great weekend, bye. Change.